Hello students, in this session we will be discussing quite a few problems on analyzing equilibrium of systems. We will try to determine the reactions of the support based on equilibrium conditions. This is one simple example. The problem is taken from Meriam Karige and we'll solve this problem. The problem says there is a uniform beam. The beam has a mass of 50 kg per meter, so the beam also has a weight. Apart from that, you have a weight of 300 kilos placed at a particular point as shown in the figure. The length of the beam is 3.6 meters. So let us draw the free body diagram for this. So I'll draw the free body diagram here. It's a simply supported beam. At A, there would be a reaction acting upwards RAY, B RBX, and one end is free, the other end is fixed. Sorry, the other end has a roller support. One end is fixed support, the other end is roller support. There is a weight of 300 kilos, which means that 3000 Newton acting downwards, and the whole beam has a mass of 500 Newton per meter. It says 50 kg, so it is 500 newtons per meter. If I have to calculate the total, the weight of the beam is going to be 500 into 3.6. As said, as shown in the figure, this distance is 2.4. This is another 1.2. So RA y plus RBY, which is the reactions upward at point A and B, should be equal to 3000 plus 500. We have two unknowns, so you need two equations. So the other equations is determined can be developed by taking moment. Moments about A would be, I'll have a moment which is going to be RBY into this 3.6, which is going to be a counterclockwise sense, and that should be equal to 3000 into 2.4, which is a clockwise sense, plus 500 into 3.6 is the force, and it acts from a point of 3.6 by 2. So from this we get, from solving this above equation, you get RBY to be equal to 2900 Newton and RAY is equal to 1900 Newton. You will have RBX to be 0 because the net force along the x direction. Thank you.